Okay, so now we're going to look at Unity and we're going to see what we can do with it pretty much. We're going to start by taking the 3D model that you made and manipulating it in a couple of different ways using C# scripts. I have a couple of meshes already from my own folders down in my project meshes folder here to use. And you should have your creature that you made in this folder ready to use in this tutorial. Or you can go and get any other 3D models from somewhere else, it doesn't really matter. So when you open Unity, this is how it looks normally, and this window here is the scene view. This is where we arrange everything and set everything up, and this window here is the game view. That means what the scene looks like through the main camera in the scene, and every scene comes with a main camera. And also, if you hit play on the game and say you have this attached to a character, you'll see that from their perspective in here. We also have our hierarchy view here. This is just like the outliner or the hypergraph in Maya. We also have our folder structure down here and a representation of all the files that we have saved in those folders. On this side we have the inspector, and so if we select something in our scene, we see all of the properties of that object here in the inspector. So I'm just going to push that out of the way for the moment because we're mostly going to be working here for the time being. Every scene comes pretty much set up with just a directional light. It's like a sunlight. It projects light in from a particular direction into the scene, and a main camera. What we want to do is start to set up an area to make some interactive content happen. So the first thing I'm going to do, just to get us started, is to create some sort of ground basically from a cube. I'm going to go up to Game Object, 3D Object, Cube, and use the Scale tool, and all of the shortcuts on the keyboard are exactly the same as in Maya. So I press R just to kind of scale out an area that I'm going to sort of make my scene in. You could also use the terrain tool or something like that, but I prefer just to work with cubes to test things. And we're going to want to make sure that, as you see in the game view, that our camera can view what's happening in that on that cube. Now I'm going to click on this cube again, and I'm going to direct your attention over to the inspector view here. And as you can see, we have our transform data that was just like quite similar to what we have over in Maya, which determines the position, the rotation and the scale of an object. I always like to make my first object appear at exactly 0, 0, 0. That makes sure that when we start working, this content isn't at some weird place. So I always just set that to 0, 0, 0. I check how that looks with the camera, and I move the camera accordingly. And you can see here my 3D objects. Say you have your object here, you can drag that into your scene if you want, just by dragging it in. Or I like to actually not do it that way. I prefer to drop my objects straight into the hierarchy, and that means they always appear at 0, 0, 0, and I control them from there. So here is my mesh, and it has a number of components. It has the transform components. It has something called a mesh filter. That's the mesh data. If I put a different mesh into here, it would change the shape of the object, and I'll just demonstrate that for you. You see, if I drag the mesh data from this other object in, it changes what mesh it is. It has an animator automatically attached. We're not going to use the animator, so you don't need to turn it off. You can turn it off there, but it doesn't really matter if you just leave it. And it also has a material, and we're not going to do materials in this tutorial, but you can just change the color of it if you want to here. Let's make it, I don't know, a nice a vaporwave teal here. And we can manipulate all of the different information in anything that you see here. Any value, any tick box, any input can be manipulated with C# code. And I want you to start thinking about objects in this three-dimensional space as not necessarily meshes or whatever. They're just a data structure in which these different inputs have been placed. So if you go to game object and you go create an empty game object, you're creating an object in the scene that has nothing nothing as a kind of a data input except for its transform data. It's simply a single point in space, and we can populate that object with things later if we want to. And we are going to use empty game objects quite a lot, because we use them as reference points for things like spawn points. If we want to make something appear out of thin air, that object will need a reference point in space to know where to appear from. So that's what we might use an empty game object for. I'm just going to delete that one. So what I'm going to do is I'm going to create my first script for this scene, and what we're going to do is make an object appear in the scene when we press a button on the keyboard. So to start explaining that and how to do that, we need to understand what a prefab is, and as well as what an instance is. So if I've got this head, I drop that into my scene. It's very small, so I'm going to change the import settings on the head like I did in the last video to be 100 and apply, and it's much bigger. You can also just scale it from there, but it's better to do it on the import because it was so small to begin with. So I've got a head here, and if I play the game, play the scene, nothing happens. It's just a static head. It's just staying there eternally. Nothing's changing. What I want to do is not have the head there from the beginning when I play the game. I want to get get Unity to grab the head from my library somewhere and put it into the scene when I press a button. So to set that up, we could delete that. Actually, I'm not going to delete that. I'm going to leave that there like that. I'm going to create a new folder in my assets called prefabs, and I'm going to open that prefabs folder, and I'm going to drag this head into there. When you drag something that you've made in here, it could be a whole set of objects together, it doesn't just have to be one. When you drag it into the library, into the folder structure, it becomes what's called a prefab. You can even go right-click and go Create Prefab and fill it up with information yourself here. So it basically functions just like an object in the main scene, except it's not in the scene, it's in your library. I'm just going to delete that other one. So we've got a prefab ready to go to make appear in the scene when we want it to. So what I'm going to do now is in my I need to put that prefab folder into the assets folder, not the meshes folder. So I've just dragged that up there. I need to create another folder, and I'm going to call it scripts. This is where we're going to make our C# scripts. I'm going to go into scripts, I'm going to right click, and we're going to create a C# script. And I'm going to call it head spawner, because when we hit a button, we're going to spawn a head. So, what I want you to do is open the C# script by double clicking on it, and we'll just wait for the mono develop software to open, which is the built-in scripting editor for Unity. And nothing is happening. Here it is. Okay. Allow access. Okay, it's just loading. Don't know why it's taking so long. It doesn't usually take this long. Here we go. And our script is here. And it comes with a couple of things. We need to look very closely at... Oh, I've got this open twice. Just close that, please. At what's going on in here. First of all, in our script, we have three things called using that Unity has added in for us. These are just references to libraries of different variables and names that Unity has built into it, and it's telling this script that we write to use those libraries of information to help it understand what's happening here. We have here the name of the class. Scripts, we can also call them classes, and so this class is called head spawner. Now, a very important thing that I'll quiz you on, no doubt, that causes many errors and people won't know what's going on. Why isn't my script working? It's because often you've called the file name something here, and in the script itself it has a differently spelled string. String means list of letters here. So this here must match exactly the text in the name of the file. Very important. We also have what's called a start function. Void in C# means a function, a start function, and an update function. Anything we put into the start function happens when the game loads or when the object that the script is attached to loads, and anything in the update function occurs every frame of the game, of the experience, whatever you want to call it. I'll just call it a game. Before our functions in our script, we want to declare what are called variables. And our variables tell the computer what kind of data and information it needs to remember in order for our functions to use that information and for them to work. Just minimize that for a second and go back to your scene view. We're going to create a spawn point for our heads to appear at. And actually we can delete this head now because it is now a prefab. I'm going to go game object create empty, and I'm going to rename it to spawn point. And I'm going to make sure that it's in a visible location. Although it is invisible, you won't be able to see this spawn point here. It won't appear any at all. And we're going to add our head spawner script to that spawn point, okay? And you can see it's here, and it's got nothing in it yet because we haven't given it any variables. So what we're going to do is declare a variable. I'm going to declare a game object variable just by typing game object. I'm going to go public game object, and I'm going to call it head to spawn. And every line we write has to end in a semicolon. Now, what's going on here? This here that appears in blue means a data type or a class type. A prefab, I need to get that out of the way. A prefab is of the type game object. So we're saying game object. We need one of those. We're making it a public game object so that it actually appears in our inspector, and if we want other scripts to access it, that's not something we'll do in this tutorial, that's more complicated. We need it to be able to see this variable if another script wants to interact with it. And here you can type anything you want. It's the name of the variable, the name of the game object we're going to spawn, the name interior to the script that is going to be used to call that. So if you save that and we wait, we should now see a thing here, a variable appear here, and it has none game object in it. If we drag our prefab into there, we're now telling the script that it must use that prefab to be that variable. That's the object we're going to spawn on the spawn point. Okay? What I'm also going to do is, technically we don't need to do this, but I'm going to do it for the sake of explaining another thing. We're going to go public, and instead of a game object, we're going to use a transform type of data. The transform data refers to all of the coordinates in a transform set of values. So we want to store a set of transform values, and we're going to call it the place to spawn. So we're going to spawn our game object head to spawn at the place to spawn. The game object is a game object, and the place to spawn is a coordinate, a set of coordinates, a transform. So we save that, and it will appear here. Now the place that we want the object to spawn is the spawn point itself, so we can actually drag the spawn point into there. And just so you understand, it's not the spawn point that is stored here, it's just the transform data of the spawn point that is stored here, because that's the type of data that it is taking. So now we need to create some sort of command to tell our head to spawn when we press something on the keyboard. I'm going to give you another variable here. It's going to be call it public, and the type of data is key code, and we're going to call it key to press. And so this will appear here, key to press, and you can actually select what key you want to press. Let's make it, let's press F to spawn our head. Okay. Now, okay, so yep, we've got our key, we've got our head, we've got our spawn point. We're hitting play. I'm pressing F. Nothing's happening. That's because we haven't created a function yet to tell this to happen. So we're not going to worry about void start at the moment. You can delete it. We're going to put something in the update section, and we're going to tell the computer every frame of the game, at every possibility for this world's existence, we want to check if you're pressing the F key, and if you press the F key, make that head appear. So we're going to create an if statement. If, and then the conditions of the statement must be contained within two brackets. If input dot get key, and in the brackets you need to put the data type of the key, the information of the data type a key. You could actually just put in like space yourself, but where we've already got a variable that represents a key code, so we can type in here key to, oops, that's key, oops, it has to be lowercase to press, and we always declare variables with lowercase letters and functions when we get to those with uppercase letters. So if the input dot get key returns a value that's equal to this key to press, that's the key code which represents F, then do something. So we've put, what we've written here is shorthand for if this returns true. The longhand for doing this, just so you understand, is to go if it equals true. So if the get key function here returns the same as key to press, and that is equal to true, then do something. We use a double equals because the equals mean, double equals means compare what's on either side of the equals. If this, it's kind of like algebra from maths. If this is true and that's true, then the condition passes. Now we open some curly brackets. We always open and close our curly brackets. So I put the open and the close here, and you can see here that the void also has, the function also has open and close brackets. That means everything between these two brackets is part of this function, and everything between these two brackets is part of this if statement. So if that's true, we're going to call a function called Instantiate, and all of these little functions that we don't have to make ourselves are part of these libraries. Instantiate, and then we want to go and just, we need to follow the structure that it comes up with, but the structure is the object to instantiate. So the object we need to put in is the head to spawn. Head to spawn. Then we need to put in the transform data that it needs to spawn at. Place to spawn. And then, okay, we need to put not Okay, so it needs to be a position, and the place to spawn, which is a set of transform data, means all of the transform data. It only wants the position data, which is actually a subset of the transform data. So you have to put place to spawn dot position, and then we also need to give it a rotation. So place to spawn dot rotation, and that means that the object that is placed in the world will inherit the spawn point's position as well as its rotation. And in class you can ask me if you want to have a different rotation and how to do that. So that means instantiate means create an instance of the game object that is its first argument, give it the position that is the second argument. An argument means kind of what data can go into a function, and this particular function has 3 arguments. It takes a game object data, a position data, and a rotation data. And if you want to look up what kind of data you want to put in an object, you need to use the Unity script reference. And this is something that you'll always have open, because you're never going to remember what all the different functions are and what the kind of data you can put into them is. So you could search for instantiate, and it would return those results for instantiate. It's and you could click here, and you can see the different kind of information you can put into that and how to do that. And I'm using this one here: object, position, and rotation. Using this and understanding how to use this will come with practice. Alright, so enough talking. We need to make sure that we end that command, that statement, with the semicolon. Let's save that and see if it works. And this would be very upsetting if it didn't work. F. Yep. I'm pressing F and it appears. It's facing the wrong way because the spawn point Z is facing that way. So if we want to fix that, we would rotate that 180 degrees. We play that again and we press F. There it is. Now, something interesting is happening here, that if we look over here, and I'm still playing the game, this is something that you need to keep your eye on. If you make any changes in this scene view while you're still playing the game, they won't save. You have to stop the game first. But I'm still playing it because I just wanted to show you what's happening in the game. There are more than one head clones here. These are the spawned heads. And we only want one, because I only pressed the F key once, right? Well, the reason that it's creating all of those heads is because every single update, every frame of the game, if that F key is down, it's going to make a new head. So it's making more than one because I had that F key held down for more than one frame. A simple solution here might be to go, instead of using get key, that means when the key is down, you go get key up, which means when the key is released. So if I save that and I press F, yep, it only comes when I put the key up, one after the other. So there's multiple heads here, but they're all on top of each other. There's many heads stacking on top of each other. Let's make this a little bit more dynamic, yeah? So we don't need to do anything here for the moment. Let's go to our head prefab and add some extra stuff. We're going to add, I'm going to explain how to give this head physics so that when they appear they are bouncy or they fall in with gravity. So we need to give the head a component, a new component, and to give it a new component you can either click here, but for some reason I never use that, I always do it up here, and we're going to give it some physics information. We're going to give it first of all, something called a collider, and I'm going to give it a sphere collider, and that means, let's just drag it in here for the moment, that means that you can see, and its colliders always appear in green. It's given it a green kind of sphere. This is an invisible mesh that determines the physical boundaries of the object. If anything touches this sphere that has collision information, it will not go through that sphere. Okay? We could also remove that sphere. We could give it a different kind of collider. We could give it a box collider, for example, if we wanted it to fall and stay flat on the ground when it was falling. And there is a couple of others in there, capsules and so on. You can also give it a physics mesh collider, where you determine the mesh, and apologies for the silly name here, I didn't anticipate that. It will inherit the mesh data of the original mesh, but that will take up more memory because there's more faces. So often you wouldn't use a mesh collider for things that are moving a lot. You might use a mesh collider for an environment that stays still, but mostly for things that move a lot, you want to give it the one of these more simple ones. So the sphere collider I'm going to use because it's going to be more fun. But at the moment it's like a static collision. If things fell at this, it would just sort of stay still and they would bounce off it. We want this to fall with gravity, so we need to give it another component called a rigid body. Rigid body and colliders are often seen together. The rigid body adds the physics and the gravity. The sphere collider gives it the boundaries. So I'm just going to leave that as it is, and we'll just test this one in the scene. Yep, you can see that falls. And this cube that we made earlier, that came, any of those ones that are produced up here come already attached with physics data. You can see it here. And the cube isn't falling because it doesn't have a rigid body. If I put a rigid body on it and this head hit it, it would fall with gravity as well. So I'm going to get rid of the first head. Oh, did I put that on here? Yes. Here's a mistake that you'll often make. You'll change the prefab here. I've added a rigid body, but I didn't change it in the library. So to make sure that I make those changes, I have to drag that back over the top. And if you accidentally drag the wrong thing to a prefab, Unity's pretty good at checking for you, and it goes, this doesn't look right. Did you really want to overwrite this prefab? And you'll say yes or no. But in this one it was similar enough that it worked. So now I'm going to get rid of that one. I'm going to make the spawn point a bit higher. And let's press F. Oh, and they're spawning, because they're spawning right on top, they're bouncing right off and probably flying into the air somewhere. They're coming down now, there we go. And they're falling perfectly in an amazing stack. Look at that. Let's make our spawn point higher then, and we're going to make them plonk, 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 plonk. There we go. they're falling really perfectly. I was expecting them to roll a bit more. You can also, in your settings here, you can add a where's the material in the the mass angular drag, interpolate, collision detection, material in the collider. You can add, oh, it hasn't got any. Usually you can add like a bouncy material or some other kind of material. It might need to be imported from a package. I might need to import the environment package. Let's see if that is right. See if we can add a bouncy material to it. Just go, yep, import all that. Yep, takes a little bit. This package has all sorts of things like water, tree creators, terrain, textures. It comes with Unity. Obviously, if you were a professional game designer, you probably wouldn't use these. These are just to sort of get you started. Here we go. Let's see if that has it. Come on. No. Okay. It must not come with this version of Unity for some reason. That's a shame. Okay, let's start doing something more interesting. So we've got our spawn point and we're hitting the keyboard to create objects. Let's move this one over. Let's also give this one a color. So this one's going to be red. So it's going to be a red head, and I'm going to make also a blue head. Oh, how about that purple head? Oh, that's the same. I need to give them a different material. Hang on. Alright, so we're going to have two different prefabs. We need to give this one a different material, whatever this one has come with. We're going to go back to our meshes, our assets. We're going to create a new folder called materials. This is just so we can see the different prefabs at work. We're going to right-click, create material, and I'm going to call it blue, and change the color to blue. Drag that onto that head, so that the other one's still using the original one, and my other prefabs using the other one. Head 1, don't replace, head 1 goes on that one, other head goes on that one. Yes. Delete those two. It's got one spawn point that's creating an object when we press F. We're going to make a new spawn point. I'm going to call it timed spawn point that creates an object every couple of seconds instead of based on the keyboard input. So we're actually going to remove this script from this one. I'm also going to make sure that this spawn point's in a different place. We're going to go to our scripts folder and then go create a new C# script and call it timed spawner. And remember, I'm giving these capital letter names, and when I'm typing the name, I don't use spacebar or underscore. I just make the next word have a capital letter. That's the standard way of naming things in Unity. I need to double click my other new script to open it. And for some reason it's opening another version of the software. Close that. I'm going to copy what I've done here. Actually, I'm not, because I don't want to change the class name. I'm just going to copy that. I'm going to put that here. And we're not going to have a key to press. And we're going to get rid of that for the moment. So we are going to have a head to spawn and a place to spawn, but we also need to create a timer. Now, we need to learn about some very common variables to make a timer, very common data types, and I'm going to list those out here. So let's go down here, go common variables, variable types. And these are variable types that are common to all of C# and JavaScripting as well, and not sort of Unity specific data types. We have, I'm going to say what the name of it is and what it's called and what it means. So an int is called an int is integer, which means a whole number. So 1, 2, 3, 100, 101, -4, -5, 500, 1,000, whatever. We've got a float, which is a floating point number. Float, which is called a float, which is equals a floating point number, and that means that it's got a decimal point. So 1.00065, -5.6789. Anything that has a fractional value and isn't a whole number is a float. So if you think about it, this really doesn't matter because our computers are so powerful now, but a float takes up more memory than an integer, because the float has to calculate all of the fractions, whereas a whole number, you don't have to do that. We have a bool, which is a boolean, which is a true or false value. So it only can have two states. It's either on or it's off. We have a string, which is a string. String is a string, which is a string of letters, like from your keyboard, or that you can type. So, and we always declare, we always type strings between inverted commas. So if I write yes, I need to write it with the inverted commas so that the computer knows where the string starts and where the string finishes. What else have we got? I can't think of anything for the moment. There's definitely more that will come up, but those are the most common ones you'll see. So to make a timer, we need to be able to store the current time and a value for the time to time out, with which is the time that we create something. So we're going to create a new variable called public, and this is going to be a float, a floating point number, a public float called timer. And this is going to be the value of the current time. We're also going to create a public float called timeout, which represents the amount of time that timer has to equal before we create an object and then reset the timer to 0. So, and this is where we have to start thinking in logic loops. We need to create a condition, a set of conditions, as well as count the value of time up every frame. So first of all, let's make our computer able to calculate time. So we're going to do that quite simply with an expression where we go timer equals timer plus equals time, I think it's capital T dot delta time. This means every frame of the game, whatever value the timer was, add to it the amount of time that has passed since the previous frame. And this little expression here means add what's on the other side of the expression. So to this variable, add what's on this side. And time itself in Unity, this is another Unity stored function, is represented by a floating point number. So that's why we can add time to a timer, because it is a float. If time was an integer, a whole point, a whole number, it would say, you can't add an integer to a float. You can't mix the data types. So anyway, every single frame we are updating timer. Let's have a look to see if that works. So we play the game. Oh, we need to select. We're not going to be able to see that because we haven't attached that script to anything. Make sure that you save that script and drag time spawn point onto the object. We see our variables here. We've got our timer and our timeout. If we play the game, we see that the timer is now increasing based on real time. Okay? The other thing to know is when you're building interactive content, you often want to use time.delta time rather than create your own sort of time scale or leave it to run based on frames, because this will always be based on a real-time clock. If you didn't use delta time and you just based it on the frame rate of the computer, faster computers would increase these values faster and slower computers would increase them slower. So that's why we have to use the built-in clock to do that, to get that equal across all machines. So every time, every update, calculate the increase in time. However, if timer is greater than or equal to timeout, then make an object appear. So let's explain this. So we could have if timer equals timeout, which means what I said before, if this value is the same as the value we set to be the time limit, excuse me, then create the object, but we're going to say if it is greater than or equal to catch any kind of errors if the computer's calculating it too fast for some reason and it skips over the value in one frame and it's not exactly equal to the timeout value, it won't work. So as long as it's greater than or equal to is better, then it's as simple as copying this expression. We do exactly the same thing. We instantiate the head, do that. And I've closed my if statement here, I've closed my function here. And clicking next to it shows where it closes and opens. Make sure you have your semicolons. If you have even one character wrong, this thing won't work. So you have to be absolutely fastidious about how you type everything out. So let's, and I'm lucky, I haven't had an error yet. So let's go timer. Oh, we haven't given timeout a value, so we can actually set that in the inspector. Let's say 2 seconds. We haven't also set up these others. We need to make sure that this spawn point is the place to spawn, and we want to have our which one did the other one have? That had the regular head. We want head 1 to be our head that we're going to spawn. So let's see if it spawns. Ah! So what's wrong here? We haven't set the timer to reset after it's timed out. So this is always returning true for every frame because it's always greater than our timeout value. So we need to make sure that we reset it, and the proper place to reset it is going to be here. Timer equals 0. It needs to happen as soon as this is placed in the scene. We're going to reset the timer to 0. If we put that, for example, and this is the kind of thing you need to be very careful about, if we put timer equals 0 here, notice that this is all contained, and you have to think like a computer. You have to think in a logic loop. Every frame, it's first going to check, it's first going to add time to our timer value. Then it's going to check if the timer has reached the timeout value yet. But if we put timer equals 0 here, that means every single update, no matter whether this happens, reset it to 0. So logically, it will always the time will always be 0 because it will always reset. Let's have a look and see if that's true. See, oh no. Well, I was wrong. I wonder why. Okay, well look, I was wrong. Logically I thought that would be the case, but doesn't matter. I'm going to reset it there. Let's see if it's fixed. Yep, and it resets, and it creates one every 2 seconds. Okay. So now let's do something else. Let's put a slope on here and see if our heads roll down the slope. Yes. And I'm pressing F, and so this one's reacting to the keyboard, and this one's reacting to time. For some reason the head appeared all the way over there, I don't know why. And let's make our scene more interesting. Let's create a new cube. Oops. And what you're going to have to do if you're one of my students is create an interesting obstacle course for whatever rolling or other kind of physics scenario you set up. I'm going to create a rotating cube here that reacts with these heads. So let's do that. Game object, 3D object, cube. We're going to make another script here. So this is going to be like a rotating object. We also need to change our main camera. Let's rotate it 90 degrees, and so we can see the whole scene. Let's just have a look at that first. FFF. Plonk. Okay. We need to create a new script. So let's go to our scripts folder and create a C# script. We're going to call it rotation, rotator. I'm going to call it rotator, and open that. And we are going to, why is this red? Okay, it's good. Update. This one's really simple. We don't even need to declare any variables. We're just going to go transform.rotate, and then the rotate function takes 3 arguments. The X, Y, and Z rotation. We're going to rotate it around the Y axis, so we can just go 0, 10, see how that looks, 0, and it doesn't, oh, that, see how that's red? It's because I've left an S out, transform.rotate. The reason we don't need to declare any variables here is because, and we didn't need to do it here either, I just did that to make a point, is we can just use the lowercase t transform, which means the transform of the object that the script is attached to. So if we attach this script to our rotating cube, then it will be that object's transform that that rotates. Let's just try that now. I've got some errors down here. You always want to check these. Actually, that one we don't need to worry about. Let's put rotator onto our, oops, we need to put it here. Here's our rotator. That might go really fast, I'm not sure. Really fast. Oh well, let's see how that goes. You can, a good idea is to practice what I said earlier, and in this value here, instead of making it 10, remember that this 10 is going to be based on the frames. So every frame increases its rotation by 10 degrees. Instead, we're going to multiply that by time.delta time to make sure that that rate is fixed between all computers. That may also slow it down. So now it's a lot slower. And how about, for testing purposes, it's good to make a public variable that represents the, that's actually a float, the float that we put here, so that we can change it more more easily. So we will create a variable. We'll go public float speed, so the rotation speed. Save that, and instead of putting 10, we'll put speed, and we'll set that here. So we'll start it at 10, And what's cool about these variables is that you can actually, while you're testing the game, you can increase them here to see the kind of value that you want it to be. I want it to be about 230, and then stop playing the game and then set that value to the one you want here. So here's our head obstacle course. Alright, I'm going to show one more thing, and then that's going to be the end of the scripting tutorial. And that's going to be a function that happens when two things collide, and we're going to make that function destroy the head that collides. So we're going to go game object and create another cube. I'm going to make that really chunky. Let's actually make them roll a bit faster by increasing that slope. So if they get through my rotating door, they're going to hit my cube and disappear. We're going to create another C# script called collision destroy. And I'm going to introduce a different kind of void, a different kind of function, and it's going to be called void OnCollision enter. This is a function that occurs when something collides with the object's collider. So this object has a box collider. This function recognizes that collider on this object when we attach this script to it, and is called when something hits it. Now we need to put something in these brackets, which is the name. So every time it collides, it's going to create a variable that's the name of whatever's hitting it, and we're going to call that other collider. I need to look that up. OnCollision enter. I always forget this. I've been using this function for years, and I always forget. OnCollision enter. Oh, it's just collision. That's the. So a collision is another data type. Don't worry about it for the moment. We're going to call it other. And then we're going to create an if statement. So any object that collides with this cube is going to be given a name, other. But we want to check if the collision belongs specifically to a head object. Let's use a tag to determine that. So we're going to actually go to our heads. We're going to create a tag. We're going to call it, we might be able to use one of these. No, we're going to add a new tag. Going to create, it's going to be called head, save. So this is a head object, and this is also going to be tagged with a head tag. And we're going to go if other dot game object dot tag is equal to head. So a tag is a string, and it's going to read the string to check that it's called that particular string. So we need to use the inverted commas. If the other game object's tag is head, then open brackets, close brackets. It's a simple command destroy, and then we just need to put in the game object that it's going to destroy, and that is other.gameObject. The reason we can't just say other is because other isn't of the data type gameObject, it's actually collision information. So we need to say the gameObject belonging to the collision information. So other.gameObject, destroy other.gameObject. And I think that's all we need to do. I have my fingers crossed that this is going to work perfectly. And every time I move out of this, by the way, I'm pressing Control S first to save it, or Command S on a Mac. I hope the head actually ends up even hitting. I don't even know if it's going to get to it. So to test that, let's just move that out of the way. And that is not working. Let me just check why. So of course I was all confused as why this wasn't working, and then I realized that I made an absolutely stupid mistake. I haven't attached my collision detection script to the wall, so that was just a stupid thing. Let's hope this works. Yes, there it is. Also, I've got a rigid body that I was testing just to see if it would work. I don't need that. So here we go. The heads roll down the hill, and they disappear when they hit the wall. The other thing I added in here was when I was bug testing it, and this is a very common thing. There's a little command you can use called debug.log, and in between the brackets you put a string. This you can put after a expression to see if it's getting through something to this, and you'll see it when you play the game. If we clear our commands, when it hits the wall it should say yes, yes, or whatever you type there. Just it helps you with bug testing. Okay? So that is enough to start on the task that, if you're one of my students, I'm going to set you in class, which is going to be to set up an interesting obstacle course and play around with things appearing and disappearing and pressing buttons to make things appear. And also you're going to have to choose what colors things are and what objects you're going to use to make this kind of a more interesting scene, a more even meaningful scene. What if this head was coming out of a specific thing? I'm only thinking of rude things right now, but what if it was Donald Trump's head and this wall was, I don't know, gun control? How can you make a meaningful scene and set of relationships on top of these functions that these interactions that I've shown you how to do? Now, you must also do something very important. In your assets folder, we're going to create another folder called scenes. You must save your scene, save scene as, save it in scenes, and we're going to call it my first scene because we're very creative, and we're going to save it in there. And you don't need to save the project, you only need to save the scenes that you're making in the project. The other thing you can do, so also I'm going to want you for homework to screen record your scene and put it onto your blog, but you can also build this as an executable, and to do that you need to open, you can either go through the build settings and choose what platform you're building it for. I'm on a PC, so I'm going to go Windows 86, and then you can build it here. This will turn it into a standalone file that you can double click on, and it will open this as a full screen application where your scene is playing out. You can also build it for WebGL, for a web-based platform if you want, and there's all these other ones there. Okay, so that is the end of the first interactivity tutorial. Actually, I'm going to show you maybe one more thing. If you want it to be a mouse click instead of a key press, you're going to use on mouse down rather than get key up. Yeah. Okay, that's it. See you in the next video.